Alright, here is a Chuck converter. It is taking 5 volts input, and the average is channel 1. Channel 1 is hooked to the output. I'll show you here. This is the converter. That's what it looks like. So on, we have our flying capacitor and inductor 1, inductor 2. Here's the diode, teeny little one in there. Output capacitor and 500 ohm load, which is 30 milliamps at 30 volts, or whatever it is, 30 milliamps at 15 volts. So that's great. So channel 1 is hooked to the output. It is DC coupled. It's yellow, and we can see it going up and down, up and down, and up and down, and up and down. And its average value full screen is minus 15 volts, which is the specification. So we have a duty cycle set up to make that happen. Just fine-tuned the duty cycle. Well, you see how that switching waveform, this channel 2 is just the same thing, same node, just AC coupled, so we can zoom in on the switching waveform. So we zoom in on the switching waveform, or V out, it looks pretty terrible. Its peak-to-peak value is 1.25 volts, which is quite not our specification. Those transients are just really terrible. Oh man, guess what? I forgot to hook up channel 2's ground lead. Watch what happens when I hook up the ground lead on channel 2. Oh man, it looks so much better, doesn't it? Howdy doody. Well, that's neat. That's great, but do you still see those switching transients in there? There's some like really nasty ones, really nasty ones. Well, this peak to peak, it's closer to the triangle wave part. It's still 450 millivolts. I don't like how big that is. The specification is 100 millivolts. Let's see if I can blow on this circuit and do something and make it be smaller. How's this? Well, that peak to peak says 220, but that's the peak to peak of the peak to peak. We're at what, 100 millivolts per division? Oop. And this is less than 100 millivolts per division. Maybe I'll put this, so I'm putting the left edge right in the middle at 50 millivolts. So then if it stays within that bound, I need more fingers. See how the triangle part is now between a division? Well, that division is 100 millivolts peak to peak. I made both specifications. Those spikes are really annoying. I don't like those spikes. Well, actually, it's a measurement thing. We know that this is a big inductor, and we have big waveforms, so let's get rid of those. And we don't do that. We're going to use this thing. There's a little bit of wire. You can use a paper clip, but this is the like $15 Keysight one. Hook it on. It's like a little spinny thing. Or it turns one way because it's a spring. And now what we have is we have probe and ground lead. Autofocus. Ground lead is much better. Autofocus, please. There it is. So now I can probe the output node and see what we get. So let's see if I can hold the camera. Here is our signal with no ground lead. And then I'm going to attach the ground lead over here. Look how beautiful that is. Focus, please. 400 millivolts peak to peak. Let's see if I can add my extra magic capacitor in here. And at the same time, I doubt it. No, I can't do it at the same time. But you saw that the triangle part was going to be lower than 100 millivolts, and then this probing technique, which this is how I have it hooked. There we go. See? Output node. This is my 0 node, and I have them kind of like sprung there, and it's a little shaky because it's a flaky connection. But when that connection is made really nice, those switching transients don't really make it any way through. It's a measurement thing and not a signal that was really in the converter.